From buying adorable clothes and having new sleeping arrangements to organizing how pets and siblings should be introduced, many expecting parents prepare for months in anticipation for their new baby. But no matter how much these families prepare their environment, there is one event they cannot prepare for, and that is having their baby diagnosed with early infantile epileptic encephalopathy. This is a rare disorder characterized by infant spasms that can last minutes and sometimes can occur over 100 times a day. Symptoms generally occur before the age of 1, but seizures often begin before the baby is even 10 days old. The mortality rate is even scarier, with 1 in 2 infants dying before the age of 2, and those who do survive manifest motor deficits, intellectual disability, and other epileptic disorders later in life. Now, some of you may be wondering, we're in 2021, there must be some sort of treatment for such a severe and early form of epilepsy. And you're right, there is a treatment. It's called anti-epileptic drugs, but the problem is that not many infants are responsive to them. Why, you may ask? Well, in recent years, DNA sequencing on the human genome has shown and identified specific genetic mutations giving rise to specific forms of epilepsy. Early infant epilepsy is one of them. My name is Nirthieca, Suthakaran, and I'm doing my part into helping transition from this outdated approach that one treatment works for all. I am studying the STXBP1 gene, whose mutations have been associated with the catastrophic infant epilepsy. And I have a great team behind me that's helping me with this. It's an army you can't even see with your naked eye. It's your friendly neighborhood nematodes. These microscopic animals are inexpensive, can answer our questions in less than 2 to 3 weeks, and don't even ask for a raise. They're not your ordinary nematodes, though, because these are humanized. Yeah, humanized. Through the power of gene editing, these worms have their own version of the STXB1 gene removed and replaced with the human STXB1 gene. It doesn't stop there, though. In other worms, variants or mutation in the STXB1 gene associated with this infant epilepsy were also installed in these worms. I administered seizures on both type of worms through our electroconvulsive seizure assay. Through the flip of the switch, the electric shock from this assay mimics that electric surge that occurs in our brain during seizures. These worms undergo convulsion and muscle twitching similar to those seen in humans that undergo seizures. My results show that variants with the STXBP1 gene installed took significantly longer to recover and had a lower survival than those with the normal functioning STXB1 gene. Now that I've identified the specific genetic mutation that causes pathogenic epileptic behavior, I'm currently looking for novel drugs to alleviate these genetic defects. The humanized worm approach works. Not only can this approach help families with infants suffering from epilepsy, but it can be streamlined to other neurological disorders affected by variants of the STXB1 gene. So, I'm here to assure you that there is hope in personalizing medicine and bringing gene-based therapy to the market, and we can do it, one nematode at a time.